Well, hello everybody, and welcome back to HansenMATH Geometry. If you are watching this video, you are obviously getting ready for our test, or quiz rather, on trigonometry, on sine, cosine, and tangent. So let this be a definitive record of the correct solutions to the 4 problems on the optional review. So in the unlikely event that there was an error with the answer key, this here will stand as record of the correct solutions with all the work shown. Okay, so if you got anything marked wrong, skip to the problem and fast forward through YouTube and take a look. So here we go. Okay, if I was a student, I'd be starting this from scratch. Okay, so let's do it. It says type in each trigonometric ratio using the side lengths labeled in the image. Do not round or simplify. Okay, so this is problem number 1. In example A, it says the tangent ratio from the reference angle of A. All right, so I'm going to grab my pen and I'm going to clearly grab angle A, which is this one here. And I'm going to think to myself, well, if it's the tangent from A as the reference angle, what does tangent mean? Well, remember SOHCAHTOA. The T stands for tangent. The O stands for opposite. So it's opposite over. The A stands for adjacent. That goes on the bottom. So remember, tangent is just a fancy word, abbreviated tan. That means from a given angle, the ratio is opposite over adjacent. Those are the parts that you compare. So from angle A, the opposite means you start from the reference angle, and I think of it like throwing a rock across the triangle through the center, and you hit the other side, bang, you hit 30. So 30 is the opposite, so that goes in right there. And then divided by, that's a divide symbol. Okay, there was no way I could do the fraction vertically with this, so I had to do it kind of sideways, if you will. The adjacent goes on the bottom of the fraction. So the adjacent, as we said in class, always connects the reference angle to the 90-degree corner. So if I draw that path in from the reference angle A to the 90-degree corner, we'd literally be tracing the side that is marked 40 in length. So that goes on the bottom of the fraction, and that is it. Okay? The tangent ratio from A is 30 over 40. All right, next. In part B asks for the sine from reference angle C. So I'm going to clearly grab reference angle C. And okay, we're dealing with sine in this one. So sine means that you're comparing opposite over hypotenuse. So if you look at this little jingle here, SOHCAHTOA, so the S stands for sine, the opposite goes on top, okay, so opposite over H for hypotenuse, that goes on the bottom of the fraction. So we're looking at opposite over hypotenuse ratio from C. So I'm going to put my pen on C, throw the rock through the triangle to hit the other side. Bang! The opposite is 15 over the hypotenuse is the largest side. So if you look at this triangle, the largest of all 3 sides, 15, 36, and 39 is 39. So that is the winner. The other way you could pick the hypotenuse is it's across from the 90-degree angle. The legs make the 90-degree angle. The hypotenuse is across from the 90-degree corner. So there you have your 39. So from angle C, the opposite is 15. The hypotenuse is 39. Okay, so there you go. I'm going to clear those folks and move up my paper. So let's look at part C and D. Okay, part C is asking for the cosine ratio from C. So I'm going to grab C as my reference angle. Here we go. And cosine, if you think about your ca, toa, C for cosine. So cosine compares adjacent on top, hypotenuse on the bottom. Okay, cosine is a fancy word meaning the ratio adjacent over hypotenuse. Okay, so if we put our marker on C, remember the adjacent always connects your reference angle to the 90-degree box. So that would be this side here, which is 9, over the hypotenuse. The hypotenuse goes on the bottom. Again, the hypotenuse is the longest side, so it has to be the 41. Or if you don't want to use that rule, find the 90-degree angle, throw a rock across to the other side, bang, you hit 41. So in this one, folks, the cosine from C is adjacent over hypotenuse, or 9 over 41. Okay, final example on question 1. What is the tangent ratio starting from C? So I'm going to grab my reference angle C right here, and I'm going to think, well, tangent, that comes from TOA. Tangent, T for tangent, opposite goes on top, over adjacent goes on the bottom of the fraction. So tangent is a fancy word for the ratio opposite compared to adjacent. All right, so again, from angle C, the opposite would be like throwing a rock through the triangle to the other side. Boom, you hit 35 over the adjacent. And we've been very consistent in class, folks. The adjacent connects the reference angle, we were told C, to the 90-degree corner. So that traces out the side that's 12 units of length. So there you have it. It's 35 over 12. Okay. I hope this makes sense. This is one of the basic things we spent some time on, being able to identify number 1, reference angle, number 2, labeling the sides, differentiating between the opposite, adjacent, and hypotenuse, and then number 3, knowing which sides are compared in each of these funky little terms, sine, cosine, and tangent. Okay, so there you go. We will mosey on now to number 2. Okay, problem 2 says, find the missing side in each triangle, round to the nearest 10th, which is one place after the decimal point. Okay, so I'm looking at triangle A, part A. I'm noting that we, in fact, do have a right angle, a right triangle, so that means we can use trigonometry, sine, cosine, tangent. But we're going to start from the non-90-degree angle. You must start from a reference angle that's acute. So we're going to start from the 20 degrees, which is right here, that angle. And we're going to label the picture, folks. We have X, which is an unknown side. We want its length. And we were given or told this length here is 17. So we need to find X, we need to use 17. We need to find X, we need to use 17. So what piece is X? Well, to trace out the X length, I would literally be connecting the reference angle to the 90-degree corner. By definition, that is always the adjacent. The adjacent connects the reference angle you pick to the 90-degree corner, no exceptions. And this 17 is the big boy. It's the biggest side. It's across from the 90. The big incline across from the 90 is always the hypotenuse. So friends, if you look at your little jingle, so ka toa, only one of these uses adjacent hypotenuse, AH. It's Ka, which stands for cosine from the reference angle, which was 20 degrees, equals adjacent goes on top, X, over hypotenuse goes on bottom, 17. That is your setup. Now, to solve for X, again, we want to get X by itself. I was very consistent in class with my messaging. The next most important thing is to eliminate the fraction. So to eliminate a fraction, you multiply by whatever's in the denominator. Since we have a 17 in the denominator, I multiply that to both sides, because whatever I do to one side, I have to do to the other side of the equation to keep the balance. So, friends, if you extend the fraction bar, you can see clearly that you have a 17 in the numerator divided by a 17 in the denominator. Anything divided by itself is one whole. So we say lazily that they cancel, meaning that we have 1 times x, which is 1 whole x. X is by itself now, which is superb. That's exactly what we wanted. Now, on the left side of the equation, this is the expression that you need to enter into your calculator. So again, remember, I recommend the Desmos Scientific. So I'm going to drag that into the screen here, and I am going to make sure I'm in degrees, which I am, and I'm literally going to press 17 cos 20. And as simple as that, notice, friends, that I get 15.97. So I'm going to write that down, 15.97. But that right now is to the hundredths place. The directions say round to the 10th. So I'm focusing on the 10th place, which is here. The 7 after it in the hundredths place is bigger than 5. So that forces us to round up. So it actually kicks this 9 up. So instead of 15.9, I've got 16.0. Technically, that is the answer rounded to the nearest 10th, 16.0. All right, I hope that solution made sense. Let me put the calculator back away, and we will use it again shortly. Okay, I'm going to erase this so that the screen is not cluttered. If you need to see it again, you can certainly rewind. The beauty of YouTube. So let's get a clean slate here, and let's look at part B. Okay, part B says we have a right triangle. That's a good thing. We have an acute reference angle, 17 degrees. Okay, that's this corner here. And we have an unknown side, x. We want to find that. And we have a given side, 17, like 17 meters, 17 inches, 17 millimeters, all right? So we need x and we know 17. We need x and we know 17. So what parts of the triangle do we have? Well, if you start at your reference angle, folks, and throw a rock through the triangle and hit the other side, bang, that's always the opposite. If we start at the reference angle and draw a straight path to the 90-degree box, that's always the adjacent. The hypotenuse is the remaining side that looks like an incline or a ramp. However, it wasn't x and it wasn't a given length, so it's not useful in this occasion. So now if we look at ka toa, we're using opposite adjacent, OA, which is the only 3 of these little jingles that uses OA. Hopefully you guessed it, TOA. T stands for the tangent function, tan, starting from a reference angle of 17 degrees. Okay, if you don't believe me because I drew a path through it, there it is. And tangent from 17 degrees equals the opposite goes on top, which was x, over the adjacent goes on the bottom of the fraction. The adjacent here was 17. because it connected the reference angle to the 90-degree corner. Okay, so now, again, very consistent. You want to eliminate the fraction to solve for x. You want to get x by itself. I'll circle x. So to undo a fraction, my friends, instead of dividing by 17, we want to multiply 17 to both sides. Okay, times 17, whatever you do to one side, do to the other. Notice that if I extend the fraction bar, you can clearly see a 17 on top divided by a 17 on the bottom. Those cancel out. You have x by itself, which is a thing of beauty. So this is the function you press into your calculator, 17 times tan 17 degrees. Note that 17 degrees is an angle measure. 17 is a side length. It's a mere coincidence that they're the same. Okay, no evil plot there. So now if I type this in, that would be 17 tan 17 degrees. And lo and behold, we get 5.19. 5.19, the directions say round to the 10th. So I'm rounding this place, but I'm looking to the hundredths. Since 9 is bigger than 5, you round up. So your solution is 5.2. Okay, and there you have it. All right, move the calculator out of sight again. And let's work on the next one. I'm going to clear the deck just so that it's not too busy. Okay, clear. Okay, part C. We have a new right triangle. Our reference angle is 59 degrees right here. So I want x and I need to use 20. So what parts of the right triangle with respect to 59 degrees are they? Well, to get from the 20 side from the 59, I have to throw the rock across the triangle, bang to the other side. That is the opposite. Okay. And this x kind of looks like an incline, right? Or a ramp. It's across from the 90-degree corner. That must be Mr. Hypotenuse. So we're going to use 20, which is the opposite. We need x, the hypotenuse. So we're playing with opposite hypotenuse. So if you look at SOHCAHTOA, of these three jingles, what's the only one that uses opposite hypotenuse? OH, OH. This one. The S stands for sine, beginning from a reference angle of 59 degrees, and it equals opposite, which is 20, over hypotenuse, which is x. Now, note that this looks different than the previous two. X was in the top of the fraction on the previous two examples. Now it's in the denominator. Okay, don't let that thwart you. Your next step is still consistent. You want to eliminate the fraction. So whatever in the bottom, you multiply that to both sides. So in this case, it's multiplied by x because that's in the denominator to both sides. Boom, boom. Okay. Now, think about what happened, folks. X is not by itself. X is over here times sine of 59 degrees. I guess I should use my degree symbol. I'm being sloppy. Equals, on the right side, you have x on top, x on bottom. Those cancel out. Pew, pew. So you're left with 20. So now, take a deep breath, do a little reality check. X is not by itself. It's not alone. It's being multiplied by sine 59. So in algebra, you're always thinking of undoing. How do you undo multiplying by sine 59? The inverse of multiply is to divide by sine 59. And whatever you do to one side, doggone it, you do it to the other to keep the balance of the equation. So you have x times sine 59 degrees divided by sine 59 degrees. Anything divided by itself divides out to 1, cancel. So you've got 1 times x is your 1x equals And over here, you have this expression, which is fractional, okay? It's 20 divided by sine 59. 20 divided by sine 59. So let's drag over our trusty Desmos calculator into the mix here. And I'm going to literally press 20 divided by, I hit the backslash, SIN 59. 23.33, which to the nearest tenth is 23.3. And this would be like meters, feet, something of that nature. It is a side length. In this case, it was the hypotenuse. All right, so that's 3 down, 1 to go as far as using sine, cosine, tangent to find unknown side lengths. So let's move on to the final step here, part D, and we'll find the value for x. All right, I can't move my screen up any further, so this will have to do. In part D, we have a right triangle. That's a good thing. That's what all this is predicated on. We will find the 52-degree angle, which is the reference angle that we were given. Note, my friends, if we connect the reference angle to the 90-degree corner, draw that path, reference angle to 90-degree corner is always the adjacent. So now I know that the 19 length side is the adjacent side. And notice that the x looks like a ramp. It's across from the 90. That is your hypotenuse. So we want the hypotenuse. It's unknown x. We need to use 19, the adjacent. Hypotenuse, adjacent, adjacent, hypotenuse. So katoa. Adjacent hypotenuse is AH. The only little jingle here that uses AH is this dude, ka, which stands for cosine from the reference angle of 52 degrees is equal to adjacent goes on top, which was 19, over hypotenuse comes last, that goes on the bottom of the fraction, that was x. Okay, so this problem is similar to the previous one. X is on the bottom. No matter whatever's on the bottom of the fraction, you multiply that to both sides. In this case, x is on the bottom of the fraction. Multiply it to both sides. However, when x is in the bottom, although they cancel, you're not done because x is not isolated. We have x times cosine of 52 degrees equals 19 is isolated, but we want x isolated. How do you get x by itself? Well, not x times anything. That's not what you want. So to undo x times, you divide. Division undoes multiplication. So you divide by cosine 52 degrees. Whatever you do to one side, you do to the other. And these will cancel. Anything divided by itself cancels to 1. So you're left with x equals this expression, which gets punched into the trusty good old calculator. Again, I like the Desmos Scientific. So I'm going to literally press 19 divided by I just checked my recording. I had a panic attack that I didn't hit record, but I believe I did. 19 divided by cos 52 is 30.86, folks, 30.86. The 8 is in the 10th place. The 6 is in the hundredths, but since that 6 is 5 or more, it's more, it kicks it up. So it becomes 30.9. Okay, that's the length of the hypotenuse. You know, it could be millimeters, inches, miles, etc. It's a length, 30.9. So there is 4 detailed solutions of how to use trigonometry to find an unknown side in a right triangle. Okay, if you need to rewind the tape, you may do that as needed. All right, so let me move my trusty calculator out the way. And we will move to question 3. Okay, question 3 says, find the measure of the angle marked question mark. Round your answer to the nearest whole degree. So now the directions changed, not 10th whole. So we will respect the directions. And we're going to look at part A. And the only thing I'm going to do, my friends, is the question mark. It does bother me. It means an unknown angle. I'm going to change the question mark to theta, which is a Greek letter. It looks like a 0 with like a tilde through it. That is the Greek letter theta, and mathematicians often use it to express an unknown angle. Okay, we talked about this in class, theta. So that's what we're looking to find. We're looking to find that reference angle right there, which is sprouting from this corner. So the next steps would be to identify what sides are illustrated in the picture. With respect to theta, what do we call the 15? What do we call the 33? Remember, the 3 names of the sides are opposite, adjacent, and hypotenuse. So what if we did the following? What if I start at the reference angle and notice that to get to the 15, I have to throw a rock through the triangle, bang, we hit the other side. That's the opposite. And note that the side that's marked 33, folks, to trace that side out, if I connect the reference angle, theta, to the 90-degree corner, that is the 33 side. From theta, or the reference angle, to the 90-degree corner is always the adjacent. That's been very consistent. Notice that the hypotenuse here is this incline. However, it's not marked. We're not going to use it for this ratio. We're going to use compare, opposite compared to adjacent. So if we go back to our lifeline here, so, ka, toa, which one of these little jingles uses opposite adjacent, OA, opposite adjacent, OA? TOA has OA. The T stands for tangent. Starting from a reference angle of we don't know, it was question mark, but sounds more professional to call it theta. And from there, the ratio of opposite to adjacent is 15 goes on top, that's your opposite, over the adjacent goes last or bottom, that was 33. Now, notice there's no X here to start multiplying. No. When you have to find an unknown angle, you have to use inverse trig. Inverse trig to find unknown angles. And on the calculator, it's going to look like sine inverse with this little -1 superscript, or cosine inverse with the little -1 superscript, or tan inverse. So how you put this in your calculator, my friends, is as follows. To get the angle, you take the inverse tangent function of 15 on top, 33 on the bottom, right? So you have to have that written down or memorized. To find angles, you use these inverse functions. So if I pull over my trusty calculator, what I'm going to do, folks, is I'm going to clear, and I'm going to find the inverse functions. They're not on my main screen. Now, on a lot of calculators like TI-84s, etc., you have to hit the second key, second tan. On this one, I have to hit the function menu, func, to get more stuff. The tangent inverse with the little -1 is right here. I'm clicking on that, and then I'm putting in my fraction, 15 on top, divided by 33, and lo and behold, it says it's 24.4 degrees, which rounded to the nearest whole. Since that 10th place 4 is not 5 or more, we lop it off. So this is a 24-degree angle. So we've got it, okay? It is 24 degrees. So let me throw my calculator off to the side. And by golly, we got it. Okay, theta is worth 24 degrees. Okay, so that's what you'd put into the box here for the question mark. All right, one down. Let's press on. I'm going to clear the slate here. Okay, part B says that the question mark reference angle is where the question mark is. I'm going to change it to theta because I think that sounds more professional. So from theta, folks, from this corner, what sides do we have? We throw the rock across through the triangle to the other side. Bam! That's the opposite. And this 18 here is the big boy. It's across from the 90-degree angle. So find your 90-degree box across. That's the hypotenuse. So now we're playing with opposite hypotenuse. Opposite hypotenuse is sine. So the sine from theta, this reference angle, is opposite, which is 14, over hypotenuse, which is 18. But again, since we're looking for the angle theta, you have to use inverse sine of 14 opposite over 18 hypotenuse. So if we get out our trusty calculator again, drag that over here. Okay, so I'm looking for the sine inverse button with the little -1 superscript. And I found it. And after that, in the parentheses, it's going to be 14 over 18. And it's 51.05. So to the whole, that is just 51 degrees. 51 degrees. All right, so again, that one used sine because we were given the opposite and the hypotenuse with respect to the reference angle. Okay, so now we'll press on to part C. So let me clear the deck and move that guy over. Okay, part C. Our reference angle in this new triangle is where the question mark is. So I'm going to mark that as theta. Theta, again, is a Greek letter for unknown angle. So from the reference angle, folks, notice that if I draw a straight path from the reference angle to the 90-degree corner, that marks this side length of 8. That is the adjacent. Okay, adjacent always takes you from reference angle to 90-degree corner. No exception. That's a good trick there. Remember, Hansen told you. And from theta, if we throw a rock across the triangle to the other side, that's always the opposite. So in this one, we're playing with opposite adjacent, SOHCAHTOA, OA, TOA, tan. This is the tangent starting from theta is equal to the opposite, which is 16, over the adjacent, which is 8. But remember, we're looking for this angle, so you have to do the inverse with the little -1 nomenclature of 16 over 8. So if I drag over the handy dandy calculator, that is going to be inverse tan of 16/8. Some of you might notice you could pre-simplify 16 over 8 to 2. Of course, you'll get the same answer. 63.4, which to the nearest whole is 63 degrees. Okay, so we solved another one. It all depends on where your reference angle is and the names of the sides from that reference angle. Remember, the hypotenuse doesn't move. It's fixed. It's always across from the 90. However, opposite and adjacent, they switch places depending where your angle is. So you have to be careful. Okay, last one here, folks, for finding unknown angles with the inverse sine, cosine, tangent. So I will finally clear this one. I cannot scroll up anymore, so we'll just have to make do. All right, now, theta in this one, the unknown angle is up here at the top, I'm going to change the question mark to theta. And I'm going to note that this side marked 7 connects the theta to the 90-degree corner. So that's the adjacent. And I'm going to note that 25 looks big and looks like the incline or ramp. So I think I know what it is, but I'm going to check. If I put my pencil or pen on the 90-degree corner and go across, yes, that is the hypotenuse. Okay. So in this one, we're playing with adjacent hypotenuse, AH, cosine from theta equals adjacent, which is 7, over hypotenuse, which is 25. And one more time, everybody remember that to find angles, you have to use the inverse. So theta is the inverse of cosine, 7 over 25. Get out your trusty no-fail calculator, and we will do clear inverse cosine 7/25. Yeehaw, 73.7. But since that 7 is 5 or more, you round up. So that would be 74 degrees, 74 degrees. That's a good room temperature. All right, so there are your solutions, my good people, using inverse trigonometry when you need to find an unknown angle. Okay, so at this point, we are going to find a couple of, not find, but solve a couple of application or story problems, and then we will have this all wrapped up. So without further delay, let's get right to it. Put away the calculator and clear. And we are in the final countdown here. Problem 4. Okay, problem 4 is 2 problems in one, 2 separate problems. Okay, part A and part B, they're completely separate. They're independent. Okay, part A, 4A, says, if you are standing 400 feet away from a building that is 850 feet tall. Okay, I'm no artist, but I can make a crude little drawing. Here's me as a stick figure. And off in the distance is a tall building. Okay, is this drawn to scale? No, I don't really care. I'm standing 400 feet away from the building, so that's measured along the ground, 400 feet. And the building is 850 feet tall. Tall or height is always vertical, straight up and down. So this is 850. And it says, I look up at an angle of blank degrees. So I'm looking up at an angle of blank degrees. I don't know. I'm going to call it theta. What is the angle? That is the question. So notice, people, that I have a 90-degree angle where the ground meets the building. And I think you can see my right triangle there in black, right? So what parts am I using here with respect to the unknown angle theta? Well, as usual, if I connect my reference angle to the 90-degree corner, that is always the adjacent. We've been very consistent. And if you start from the reference angle and throw a rock across through the triangle and hit the other side, that's the opposite. Okay, the hypotenuse would be like if we stretched a piece of rope from the top of the building to the ground, like a rope or like a ladder leaning, which that would be a bad angle, it would collapse. But anyway, my picture is not drawn to scale. So the hypotenuse, which for the record is right here, don't know, don't care. We know the opposite, we know the adjacent. Opposite adjacent is tan. Okay, so your work would be tan theta, unknown angle, equals OA, opposite over adjacent, 850 over 400. But remember, when you're finding the angle, you must use the inverse. Tan with the little -1 nomenclature, parentheses 850 divided by 400. Okay, that will find us our unknown angle that we're looking up at the building. So if we drag the calculator back into the mix, I would literally be pressing inverse tangent of 850 divided by 400, and boom, we get 64.7, and it said round to the nearest whole. So 64.7 would round up to 65 whole degrees. 65 whole degrees. That is your angle. Okay, that's fairly steep. Okay, remember, looking straight up would be 90 degrees. Looking halfway between the ground, like the horizon, and straight up is 45. So this is steeper than 45. Okay, you're not looking straight up, but you're not looking like split between like, you know, the floor and the wall kind of an angle either. So there you have it, 65 degrees. Okay. I think I may leave that one up on the screen. Let's see. Yeah, that'd be okay. All right, part B, completely different problem. A ladder is leaning up against a house. Okay, so here is expertly drawn as usual. Here is house. And here is a ladder leaning. Okay, here's like the rungs of the ladder. And I can notice now here, I'm going to have to make this a little bit bigger. Okay, so let me expand it. Okay, house, roof, windows, door, expertly drawn as usual. And in brown, ladder with the steps or the rungs. There we go. It says the ladder is leaning against a house and makes a 35-degree angle with the ground. So I need to put in the ground, and there's going to be a 35 degrees between the ground and the ladder. So that goes right here, folks. This is your reference angle right there, 35 degrees. It says the foot of the ladder is 7 feet from the foot of the house, just like your feet, they're on the bottom or ground. So that's 7. Note that where the ground meets the house is a 90-degree angle. It says this means the ladder is blank feet long. So that means my brown ladder is literally what we're measuring, not the height of the house. Okay, that's another question. The height of the house, but no, this asks for the ladder, which is literally leaning like that. That's X. So let's think about what's going on here. Our reference point is 35 degrees. What pieces do we have? Well, if we connect the reference angle to the 90-degree corner, we've talked ad nauseum that that's adjacent, and the incline or the leaning side that's across from the 90 degrees, that is the hypotenuse. So we want the hypotenuse, we know the adjacent. We want the hypotenuse, we know the adjacent. Which function relates adjacent and hypotenuse? Cosine. So we've got the cosine starting from 35 degrees is equal to the adjacent, which is 7, over the hypotenuse, which is X. Okay, this is reminiscent of the problems we did earlier, and our next step was consistent. Whatever was in the bottom of the fraction, we multiply that to both sides. So instead of dividing by X, we're going to multiply X to both sides like this. Okay, note when you have X on top and X on bottom, they cancel, leaving us with just 7. I'm going to bring that down. Equals, and I'm going to bring this down, X times cos 35 degrees. Note that if I circle X, it's not isolated. There's an operation happening to it. Times, multiply cos 35. How do you undo multiply cos 35? Divide by cos 35. Whatever you do to one side, do to the other. And then, folks, you have cosine 35 divided by itself cancels to one whole. That leaves you with your x. Bring that down, equals this beautiful expression, 7 divided by cos 35. So if I bring over my calculator and I press exactly that, 7 divided by cos 35, we get 8.54. It says round to the nearest tenth, so that's 8.5. 8.5. Get out of there. So it's 8.5, and since this is a story problem, there should be some units. So this would be 8.5 feet. And that is a wrap. So remember that cosine is opposite over hypotenuse. Nope, I misspoke. Sine is opposite over hypotenuse. Sine is opposite over hypotenuse. Cosine is adjacent over hypotenuse. And tangent is opposite over adjacent. So if you think about where's your reference angle, labeling your sides, and setting up the ratio, that will go a super long way to getting the problems right, along with using a good calculator like a TI or the free Desmos Scientific, which is available via the URL website, desmos.com/scientific, or the iOS store or the Android store for free. And I don't even get a cent of commission for recommending it. So sad. All right, folks, if you've made it this far, this concludes the solutions to the bonus trigonometry review. So if you are hearing my voice and studying for your quiz, good luck to you all. And I hope you score well and make yourself proud. Okay, thanks a lot. Good luck, and we'll see you next time in class.